All right, we're going to take a look at chemical equations. These are basically representations of a chemical reaction and use symbols to represent it. And we're going to go over the different symbols that you'll see in a typical chemical equation. So first off, if you see an S in parentheses next to a chemical, that tells you that the state exists as a solid. If you see a triangle inside the reaction, usually above the arrows, it's telling you that in that situation you're adding heat to the reaction. So triangle means heat. When you see liquid, which is not any of these two reactions, it basically tells you have a liquid. When you see a double arrow, it tells you the reaction is reversible. Could go either way. So reversible. G stands for gas. And AQ, which is not in any of these reactions either, basically tells you dissolved in water. So it means whatever chemical it is, it's mixed in water. So it's a solution. You basically have a solid dissolved in water, and that's why you have aqueous. So SL and G basically are different states of matter. AQ dissolved in water. The arrow, if it's a single arrow, means the reaction goes only one way. You can only go from reactants to products. If you see a double arrow, it tells you reversible. So that means that you will react nitrogen with hydrogen to produce ammonia, but the reaction can also go reverse. You could do things to make it go the other way. And triangle means the reaction is reversible. All right, so let's take a look at how to write these reactions out if you're given the chemicals in named form. So solid calcium carbonate. So this is an ionic compound, the way we could tell. Remember, it's a metal, part of the compound, you have a nonmetal. So calcium is Ca positive 2, it's a group 2 element. Carbonate's a polyatomic ion, negative 2. So if we're writing calcium carbonate, it's Ca, CO3, and it tells us it's a solid. Decomposes, that just means it breaks apart. We know that produce is our tip-off, that these are our products, so that's why we're going to start by putting our arrow in first. You have solid calcium oxide. So calcium is a positive 2. Oxide's a negative 2. So if you crisscross this again, remember, because just like this, it's the same charge for both of them. It's a 1-to-1 ratio. This should become CaO. And you have carbon dioxide. So carbon dioxide, there is no metal in carbon dioxide. Both oxygen and carbon are basically nonmetals. So when we're doing the formula for it, we're using prefixes. There is no charges, no crisscrossing. So that's just CO2. And I forgot to put the state for calcium oxide is solid because they gave that to me. And carbon dioxide gas, CO2 gas. So that's how you write the reaction out based on just the words. So you should be able to do this using your understanding of formula writing of both molecular and ionic compounds. Next thing I want to point out is your diatomics. So these are very unique elements. These are elements that do not exist by themselves. So easy way to remember is just Hofbrinkel. What's so special about them? You can't ever write hydrogen by itself. It's either in a compound, like an H2O, or OH minus, or H3O, positive 1. And there's a lot of varieties of this. Or it's by itself, and it's going to be bonded to another version of itself. So either hydrogen is going to be found in a diatomic form with a little subscript 2, or it's in a compound. You will never see just this. Now, theoretically, you could see this, but that's hydrogen ion. That's not the same thing as just hydrogen, the molecule. And if you notice in the example below, we have hydrogen gas. So you can't write hydrogen gas like this. That's indicating it's an ion, it's an aqueous form, so that doesn't work. Same thing with oxygen. So we don't write oxygen as O, we write as O2. Same thing with fluorine, and so on and so forth. So all these, if they don't give it to you in the form of a compound, you write the little subscript 2 to indicate they're diatomic. And we'll show how that plays out right underneath this. So here you have hydrogen gas. So I write it H2 because it's a diatomic. It's one of the Hofbrinkel ones. And oxygen. So remember, oxygen is diatomic as well. So write that. Combines to produce liquid water. So liquid water is just H2O liquid. There you go. So pay attention to these diatomics, make sure you memorize them because they'll help you write the correct formula if you get something like this where I give you the words and you're supposed to figure out the names in formula form. All right, last thing, balancing. So the basics of balancing is that what you're trying to do is make sure you have equal numbers of each element on the left and right side of the arrow. This is called the law of conservation of mass. So here we have 2 hydrogens, we have 2 oxygens. Here we have 2 hydrogens and 1 oxygen. The way I identify that, the subscript tells you how many you have. So there's the 2 for the hydrogen. There's a 2 for the oxygen, there's 2 for the hydrogen, and there is no number here, so we assume it's just a 1. So there's 1 oxygen. So we have 2 hydrogens, 2 oxygens, 1 oxygen, 2 hydrogens. So how do we balance it? What we're trying to do is make sure you have the same number of elements on both sides. So if you look at the first example, 2 H's, 2 O's, 2 H's, 2 O's, that's correct, but remember, it's a diatomic. You can't have O by itself. So this formula is a no-go. That's why it's crossed out. Looking at the example underneath, you still have 2 H's, you have 2 O's, you have 2 H's, 2 O's. But here, I no longer have water. This is referred to as hydrogen peroxide. That's a whole different chemical. So you can't balance by putting a 2 at the end of the formula. That's a no-go. You can't change the identity of the chemical. The only thing you're allowed is put numbers in front. So let's take a look at this last example. Here, now we have 4 hydrogens, 2 oxygens, and 4 hydrogens and 2 oxygens. That's balanced. And some of you guys can't say, well, now you have 4 hydrogens, you originally had 2. That's the only way to balance this. So in order to make this work, you have to put a 2 in front of H2 to give you 4 hydrogens, because what you're trying to do is give yourself 2 O's on this side. And by doing so, you force the hydrogen to go from 2, which originally was, to 4. So I have to fix that. So that's why I put a 2. So the only thing you're allowed to do in balancing is to put numbers in front. And we'll go into more detail about balancing, how to interpret it. The only thing I want you to understand right now is that when you're trying to balance, the only thing you're allowed is to put numbers in front to make sure that you have equal numbers of each element on both sides. And that would be our examples of chemical equations in a nutshell.